You should time your code. Whether you're programming in a fast compiled language like C or C++, or in a slow interpreted language like Python, timing your code gives you a bunch of benefits. You can determine whether your program works right. You can determine whether there are any bugs or glitches you can fix, and if the solution you're presenting is the most effective one out there. In Python, there are a bunch of ways to time your script, but the most effective one appears to be the Timeit module. It takes your code as a string and runs it over 1,000,000 times for you to determine the average code runtime. For those of you who are more experienced with Python, you may wonder, why don't we use the time module? Because it's just 2 lines of code instead of converting the whole code to a string. Well, there's a big problem with this module. Let me show you. Here I've got a cool little generate grid function that basically generates grid just like this, depending on width and height. And now I import the time module, I assign the time.time to a start variable, and then I run the pretty print on that grid and print the time difference between when I started printing and when I ended printing. And as you can see, if I run this, we get 0.008. Now run it a couple more times, 0.013, 0.003, 0.005, and even right now you can see the big difference between each run of the code. And that isn't supposed to happen. But that's not the thing I was talking about. Let me show you the other thing. Alright, right now I have CSGO, Minecraft, PowerPoint, VS Code and Google Chrome opened at the same time on my computer. Let's see if something has changed with our program runtime. See, 0.016. Now it's stable 0.015, 0.16, and before it was stable 0.0004, 0.003, and the maximum was 0.013. I don't know if I can find. Yes, here it is. And now the code runs slower because I have, see again, 0.004. The difference between each run of this script is very big. As you can see, 0.031, that's like the record here. And as you can see, each background process has some influence on the whole code time. And ideally, when you time your code, you don't want that. So that's why the time module isn't good to use, because every background process you run on your PC will be taken into consideration when you time your code with time module. If you are still watching the video, please like it. It means the world to me and it makes me very, very happy. Thank you. As you just saw, the time module does not account for background processes running. That's why Timeit isolates your code in a string so that no background processes will get in the way of you timing your code. But putting it all in one string is such a pain. Your code literally doubles when you do that. But there are some life hacks to avoid this. One of them is called string formatting. Let me show you. Here I've got the same generate grid function, but this time I'm gonna be timing it with the Timeit module. We're gonna be using the timeit.timeit method for it. It takes 4 arguments, which is setup, which is the code you need to run before timing your main chunk of code. Then stmt is the main code you want to time. Then you have timer, which is the timeit.timer object. We don't need to worry about it because it has a sensible default value. And then we can put it a number, which signifies the number of tries we want to run our code over and over again to finally get the average. But we need to keep in mind that timeit.timeit returns the time that it took to run number of times our program. So it's like the time variable here is our program ran number of times, and we divide it by ourselves to find the average time it took to run our program throughout the number of times. Almost every value here is by default except the STMT, so we need to put in a STMT to test our code. Number, I believe, is 1 million by default. Here I put 10,000 because the program is going to run too long if I put in more. So basically that's how it works. And now about the string formatting and the whole string thing. Well, what you would usually do is just take this whole function and put it in a string like this, and then assign it to some variable like this, for example, and you got yourself a ready variable. Here it won't work because it has some documentation, but we don't need to worry about that because we are not going to be doing that either. So if I remove all the codes here we have some different string, I'd say. Here we actually use the setup code. Instead of like jamming all of this code into a variable here, we use our setup code, which is basically a formatted string from main import function to test name. Now what does this mean? This is basically means from main import generate grid, because it's a string formatting. I can obviously put generate grid here instead of a string, but I decided to do it so that I can put multiple functions in here. For example, I have a func2test variable here, which is generate grid function. It has like the link to the generate grid function. I can put a link to another function and it will work exactly the same. Here I got width and height, which are the variables we are passing to this function, and here in test code, this is the code I will run to test how long it takes to make it all. And here, as you can see, I got func2test name, height, and width. It's basically this here is the same as this. Generate grid, height, width. For you to understand, the func2test is generate grid, and the name is, it just like gives a string the name of the function. Because if I just put function to test here, it will not work because it's a string, so it just needs a name, and the name is in the string, so that's how it works. And here it's actually f strings. If you don't know what it is, you can just like read about it in the internet. And we pass height and width here to this function, so it's just a basic string formatting. And then we pass that string as test code here and the setup as setup code here. And also I decided to make, as I already said, number a bit lower so it won't take that much time to run. Now let's see how much time it takes to run a singular piece of code. Because as you can see, I divide the whole time by the number of tries. Let's try it out. See, this is the time it took to run basically one time this piece of code on average. So it just ran it 10,000 times, and then through this equation I got the average out of those 10,000 tries and the size of average run. But as you can see, it's much lower than it was with Timeit, and that's because I forgot to do something. Let me quickly change it. I need pretty print because the time had pretty print, and this just like calls a function, so I need to change it. What the hell is happening? Oh, it prints the thing 10,000 times. Oh my god. Okay, so I understood a bit of a problem with the method I want to do, because over there in the time file it printed the grid only once, because we ran it once, and here I ran it 10,000 times, so the grid is printed 10,000 times. Anyway, I think we should just show you this, because see, again, I run my code, it's 2.58, like this is a very small number for you to understand, it's just like it's incredibly small. And if I run it a couple more times, see, the difference always stays here. I mean, yeah, there is some difference, but that difference is so small that it doesn't matter. And it's average, you know, so every time I run the average number. If I just remove it and try to run time. I'd get 0.26, 23, 23, 23, 22, 22, 23, 23, 22, and even right here you can see that the difference isn't as big as it was with the time module. So that's why you should use the Timeit module, and basically that's how you use it. So that's all there is to it. Thanks for watching. Don't forget to like, subscribe and comment if you like this type of content. I'm trying to post one video a month right now, as my schedule is very busy, so please subscribe, it would mean the world to me. Also, I'm running low on video ideas, so write yours in the comments below. Have a good day and bye!